The Great Wall of China is not a single wall, Aletheus. It is a symbol, a myth. But beneath the myth, it is something far more tangible, a logistical problem. We see the stone and brick, but we fail to see the invisible network that put it there. The true marvel is not the structure itself, but the continent-spanning supply chain that built it. A system encoded in the very bricks of its watchtowers. Now, let's open the historical ledger and analyze the economic blueprint this crisis left behind. To comprehend the Great Wall, specifically the vast sections built during the Ming Dynasty, we must first deconstruct the scale of the challenge. It is, perhaps, the largest single infrastructure project in human history. The common perception is one of a monolithic barrier, but the reality is a complex defensive system stretching over thousands of kilometers. And this system was not built in a vacuum. Its catalyst was a profound systemic shock. In 1449, the Ming Empire faced its nadir, the Tumu crisis. The Zhengtong Emperor was captured in battle by the Mongols, a humiliation that exposed the terminal vulnerability of the state. The old offensive strategies had failed. The status quo ante, a forward policy of cavalry garrisons, was shattered. The political and strategic consequence was a monumental pivot. The Ming would turn inward, adopting a new grant. The wall was the answer. But this answer posed an almost impossible economic question. The sheer numbers are staggering. We are not talking about a few fortresses, but we are talking about a network of perhaps 25,000 watchtowers and nearly 9,000 kilometers of wall. Forget the myth of a single continuous barrier. Focus on the logistical reality. The core components were earth, stone, and, crucially, billions of standardized, fired bricks.
This is where our analysis begins, with the humble brick. Each one is a data point.
To build the iconic crenellated ramparts and towers, the Ming state needed to create and operate the largest This is the impossible blueprint. Supply and economic framework. A project of this scale faces three primary points of friction: materials, labor, and finance. First, materials. Sourcing stone in mountainous regions was straightforward, but the real logistical challenge was the brick.
High-quality, kiln-fired bricks were essential for the watchtowers and key structural sections.
This required few. The Ming government didn't just build a wall. It had to industrialize brick production across northern China. This wasn't a centralized operation. It was a vast, decentralized sourcing network. We know this because of the bricks themselves. Many were stamped with QE, characters indicating their origin, the kiln. This is the historical ledger. It reveals a framework of accountability and standardization. Second, labor. The project required millions of workers over 2 centuries. This labor was not a single, standing learning nilders. It was a complex, multi-layered system of mobilization. There was a garrison soldiers of the Neural-Cytierkarines, who relied into primary military labor. There were conscripted civilians, a form of taxation paid in current and sweat. And there were convicts, a workforce of exiles paying their get to the state. Organizing, feeding, and equipping this multifaceted workforce across a 5,000-mile-long construction site is a problem of systemic complexity. Third, finance. How do you fund the impossible? The Ming tax base was notoriously rigid, based primarily on agriculture. A project of this magnitude could not be funded by the central treasury alone. The financial mechanisms were a patchwork of innovations. We see the Zomshang system, or a merchant trading policy, where the government traded a monopoly on salt for critical steel. This effectively converted private merchant capital into logistical support for the wall. It was a brilliant, if desperate, fiscal policy shift, turning the profit motive into a tool of national defense. So, the blueprint we are deconstructing is not one of stone, but one of systems. It is an economic, logistical, and administrative framework designed to overcome the friction of geography, the constraints of a pre-industrial economy, and the sheer scale of the vision. The Tuhu crisis was the catalyst, but the wall itself was a consequence of economic organization. The challenge was not just to pile stones. It was to create a conveyor belt that stretched across a continent. The metaphor of a conveyor belt is almost too clean, too modern. The reality of the Ming supply chain was a far messier, more complex, and ultimately more fascinating system. It was not a single, fluid mechanism, but a multi-layered, often overlapping, and adaptive framework. To deconstruct this Continental Conveyor, we must analyze its three primary currents. The flow of material. Let's begin with the materials, and specifically, the data encoded in the bricks. This is our first point of quantitative analysis. When we look at a Ming-era watchtower brick, we are not just looking at a building material. We are looking at a unit of production, a data point in a vast ledger. The stamps carved into them, the key, are a form of pre-industrial quality control and supply chain management.
Kiln,
They tell us
supervisor,
which kiln,
locality.
which supervisor, and which locality produced it. This busts a common economic myth that the wall was a top-down, centrally manufactured project. The brick data proves the opposite. The Ming state did not build a few colossal factories. Instead, it leveraged a decentralized network of thousands of local kilns. This was a pull system. The state set the standards, the quotas, and the brutal penalties for failure. This policy had a profound structural impact. It forced the industrialization of the frontier, creating localized economic zones wholly dependent on the wall's construction schedule. The state didn't have to manage the logistics of hauling every brick from a central source, as it outsourced the production to the localities closest to the construction front. This was a brilliant adaptation to the immense geographical friction. The second current was labor, the who of the construction. Again, the system was layered. The first layer was the military. The main frontier was divided into 9 zhenshao, or defensive commands. The hundreds of thousands of soldiers garrisoned there were the primary workforce. This is a critical economic distinction. This was not a wage labor economy. The second layer was conscripted labor. This was a form of taxation levied on the local populace. This was a massive, disruptive economic shock to the agricultural rhythm of the North. It pulled farmers from their fields, creating a constant tension between the demands of national defense and the necessity of food production. The state was, in effect, performing a constant, painful calibration. How much labor could it extract from the farm economy before that economy collapsed and could no longer feed the soldiers? The third layer was penal labor. Convicts and exiles were sent to the wall, a via dolorosa of the Ming justice system. For them, the wall was a life sentence of hard labor. Economically, this was the cheapest labor pool, but it was also the least motivated and most difficult to manage. Now we have our materials, decentralized bricks, and our labor, a multi-layered workforce of soldiers, conscripts, and convicts. What connects them? What economic engine powers the entire, sprawling construction site? The answer is not silver. The answer is grain. The single greatest logistical challenge of the Great Wall was not engineering, it was calories. The northern frontier was arid, cold, and poorly suited to high-yield agriculture. The grain had to come from the south, from the fertile Yangtze River Valley, hundreds, even thousands of kilometers away. The grain had to come from the south, from the fertile Yangtze River Valley, hundreds, even thousands of kilometers away. The cost of transport was astronomical. It was estimated that by the time a bushel of grain from the south reached the frontier, the transportation cost was 10 times the value of the grain itself. This level of friction, this logistical cost, would bankrupt any state. The main solution was a masterpiece of fiscal balancing amid a recognition of market forces.
It was called the Zongshan Fista, or the Merchant Trading Policy.
This policy is the true, hero, economic framework of the Great Wall. Here is the mechanism. The state held a monopoly on salt, the vital commodity for preserving food. Private merchants were forbidden from trading it. The Zongshan policy created a direct link between this monopoly and the frontier. The state told the merchants, you deliver 1 shion, about 100 kilograms of grain, to this specific frontier garrison, that we will give you 1 yanim, a voucher or a state-sanctioned certificate to trade a set amount of salt. This was genius. The state did not have to manage the transport of grain. It harnessed the profit motive and expertise of the private merchant class. The merchants, with their own capital, networks, and logistical capabilities, figured out the cheapest, most efficient way to get grain to the frontier. A problem the state bureaucracy had failed to solve.
In exchange, they got the yanin, the golden ticket to participate in the more hyper-lucrative salt trade.
The state effectively converted a commodity it controlled, salt, into the resource it desperately needed, frontier grain, using the merchants as the logistical and financial intermediary. The system was the Continental Conveyor. It was a policy shift that recognized the limits of state power and leveraged private capital to solve a public crisis. It was a data-driven system based on precise calculations of grain needs and salt voucher that. And it was a power shift, creating an immensely wealthy and powerful class of frontier merchants whose fortunes this mechanism, this flow of grain per salt, is what cemented the bricks together. The long-term consequences of this immense logistical operation were as vast and structural as the wall itself. The Ming Dynasty, by committing to this impossible blueprint, fundamentally reshaped its own economy, creating a structural dependency that would, in turn, prove fatal. This Continental Conveyor belt, fueled by grain for salt, was a high-friction system. It created a massive, permanent distortion in the Chinese economy. The entire north became a militarized economic zone, a vast garrison that did not produce its own sustenance. What was instead evaded by a complex, long distance umbilical cord to the vertebral serval. This locked the state into a fixed, astronomical cost. The wall was not a one-time purchase, it was a subscription. And the payments were a crushing burden on the imperial budget. Furthermore, the financial mechanism that powered it, the Zhongshang system, contained the seeds of its own destruction. While brilliant in its inception, the system was vulnerable to political and financial desperation. As military pressures mounted, the state began to cheat. It issued more Yangyun, the salt vouchers, than its salt monopoly could actually are. This is a familiar story to any student of economic history. It was a form of seigniorage, a debasement of the currency. The salt vouchers, once a golden ticket, began to lose their value. The merchants milled. This triggered a cascading failure. Without the merchants' grain, the frontier garrisons starved. Soldiers deserted in droves, and the wall's defenses crumbled from within. The very system built to save the dynasty, in the end, accelerated its collapse. This brings us to our modern parallel. The Great Wall is not merely a historical artifact. It is a data-driven case study in the timeless challenges of
Today, we no longer build physical walls of stone,
but even greater complexity.
but we operate
The
within a
global supply
logistical
chain.
framework.
This is our Continental Conveyor. The core problems of the Ming, friction, distance, and cost, are the same problems that define our modern world. We have simply hidden them behind container ships, financial derivatives, and just-in-time manufacturing. The Ming's reliance on the Zhongshang system is a direct parallel to our modern reliance on complex financial instruments and single-source dependencies. The Ming state's currency was salt vouchers. Ours is the intricate web of letters of credit, futures contract. What happens when that system is shocked? The tomb crisis of 1449 that catalyzed the wall's construction. There's no different than the modern shocks that fracture our own supply chains. The pandemic, a geopolitical conflict, a single ship stuck in a canal. Suddenly, the friction that was once invisible becomes painfully real. The Ming discovered that the cost of moving grain could be 10 times the value of the grain itself. We discovered that the cost of moving a shipping container could spike by 1,000%, and that the wall of our month, the brick stamps on a Ming watchtower, are a lesson in decentralized, accountable production. Tombs. The entire Great Wall framework serves as a historical blueprint, a cognitive scaffold, allowing us to analyze. The Great Wall, in the end, teaches us that the most powerful systems are not made of stone. They are made of information, trust, and the delicate calibration of resources. The historical ledger of the Ming is a mirror, reflecting the same timeless forces of friction, leverage, and systemic risk that shape our world today. The lesson is that a supply chain is not just a network. It is the central nervous system of an economy. And its resilience, or its fragility, often determines the fate of empires.